Bismillahirrahmanirrahim. Today we are going to start second session of our lecture number 4 in operating systems course. Before to start our second session, we will just take a quick overview of our first session in lecture number 4. In first session, we said that this session belongs to our course learning outcome number 4, in which the explained operating system support for process, threads, scheduling, synchronization, deadlock, virtual memory, and file system. We start our discussion from inter-process communication, and we said that inter-process communication is the communication between processes, and when the processes communicate with each other, it is called inter-process communication. And why this communication is important, we have also given some example, and one of them is maybe the output of first process need to pass to the second one, and so on to other process. So there are many different reasons that one process communicate with another process. So this concept is called inter-process communication. Then we discuss the process control block, and we said the process control block also called process task control block, and it is a way that how the process is represented in the operating system. And we have few things: process state, process number, program counter, registers, memory limit, list of open files, and so on. So these are the component of process control block. So then one by one we discuss the process state. Already we know that we have 5 different states: ready, new, ready, running, waiting, and termination. And program counter, that is that program counter indicate the address of next instruction to be executed for this process. So this is responsibility of program counter to tell to the processor which instruction you have to execute next. Then we have CPU register. That is very important concept, that how many CPU registers. The registers in operating system vary in number and type, and it depend on the architecture that we are using. And mainly in all the architecture you will find accumulators, you will find index registers, stack pointers, and general purpose registers. Okay, so all these registers, these are common registers that will be available. So they have different responsibility, like accumulator, which are used to store intermediate arithmetic and logic results. Index registers are used for modifying the operand address during runtime of the program. Stack pointers used to give the address of stack area. Okay, and where because we know that in stack area we have local variables, parameter to subroutine or function. Okay, so general purpose register, that is a small amount of storage which is available on the CPU. So these are the main CPU registers that are available in almost all different type of computer architectures. Then we have seen CPU scheduling information, and this scheduling information include priority pointers to scheduling and any other scheduling parameter. So how to schedule which process we have to execute. First, the more detail you will get in week number 6, lecture slides of week number 6 about scheduling information. So then we have memory management information. We already discussed this include the value of base and limit register, page table, segmentation, and many things. These are also a very big topic that we will discuss in coming lectures. Then we have accounting information, and this information includes the amount of CPU and real time use, time limits, account number, job number, process number, and all these information which are related to accounting, that will be also part of process control block. Then we have IO status information, and in the IO status information include the list of IO devices allocated to process, list of open files, so everything that are related to input output. So this information we need to store, which will be part of process control block. So also we discuss one example, that how CPU is switch from process to process. We have seen that we have one process P0 and one process P1, and this diagram we explain in detail that whenever we are going to stop any process, we need to his current state in process control block, and whenever we have to start any process for execution again, so then we need to reload his state from process control block, and so on. So to save and to reload. Then we discuss time sharing. What is the objective of time sharing? Is to switch the CPU among the process. In last, that here if you see, actually this is time sharing. We have one processor and we are switching among many processes. Here this example of only two processes, but actually in our system we have many processes currently running. So how CPU is switching from one process to another process? It's very fast. Okay, so this is called, the concept is called time sharing, that we are sharing the time of CPU. Then at the end we discuss in first session of lecture number 4 that process scheduler and process identifier. So what is scheduler? The purpose of scheduler is to select an available process, possibly from a set of several processes for program executing on the CPU. So there will be many processes available, but the scheduler will select one process and it will give to the CPU for execution, or maybe you can say that it will move from ready state to running state for execution. Then process identifier, it is used to uniquely identify a process. Okay, so we finish our discussion up to this slide. Now we will continue our next, that what are the operations on process. Okay, before again, what is process? A process is an instance of a computer program. Okay, so this is a process. So when we discuss operations, how many operations? We have two main operations that we can perform on process, that is process creation and process termination. How we can create a process and how we can terminate a process. So actually these concepts are related to the lab session, but here just brief theoretical knowledge about how we can create process and how we can terminate process. Okay, so what is process creation? The first thing, process creation, that a process may create several new processes. Okay, so one process can create many other processes, and how it will create? By using create process system call. So we will take help from system call that to create a process. So here how we can create process? The system call normally that we will use in lab, that is fork. Fork is the command that we can use to create a new process. So when we will create a new process, we will use this command, then that process will be child process. Okay, so parent, then we have the concept of parent and child. Parent process, the creating process is called the parent process. The process that will create another process, that is called parent, and the new process is called the child of that process. Okay, so which system call we will use to create a process? That is the fork. Okay, so process creation is to create a new process, and one process can create many other processes, and these will be called child of that process, and the process who is going to create a process, it will be called parent process. So we have here concept of parent and child, parent process and child process. Now if you see in this slide, this diagram, okay, each of these new process may in turn create other process which forming a tree of process. So here this is a tree format. Let's suppose we have this one first process and second, and this process, this is called root. This is a root main process. In tree we use this, the first, this is root. Okay, and this process has created three processes, that is this login. Okay, K thread and SSHD. So don't worry about the name of the process, but the important thing is how many process he has created. 3 process. So these 3 process are child of this process. Okay, so this process then created one child, this process created 2 more process, and this created one process, and this created one process, and here this no process, no, and here he has created 2 process. But important thing, if you notice here the process ID, PID, okay, so in this tree you will not find any process have duplicate ID, same ID. The process ID must be unique. If you go back and see in process ID, each process they must have some process ID. Okay, so this is related to creation, how we can create a new process. Okay, so understand, the creation mean to create new process. So one process can create many other process. Here the root created 3, and then some process they created 1, some process they created 2 more process, and some 0, like this last they have no child. Okay, so the thing, one process can create many other process, but in the process ID must be unique. Suppose the root, the process ID is 1, and if you see, you will not find the process ID 1 for any other process in this tree. Let's suppose if you see that process, I say this process login, the process ID is 8415. So you will not find any other process with that have same ID 8415. So process ID must be unique, not same. Okay. Now the second operation that on process, that is process termination. Okay. So process termination mean how we can delete process. That is the thing. The process termination, when it finish executing its final statement and ask the operating system to delete it by using exit system call. So this is also again we can take help from system call to delete a process. So which system call we can use to delete the process? Exit. Okay, so when a process finishes work, of course we don't need that process. So how we can delete that process? We can use exit system call to delete that process from memory. Also it will clear your memory space. Okay, so whenever the work is finished, we need to delete that. So here when the process have finished its work, so we can use exit system call to delete. Again in lab we will perform how we can create process, how we can delete process. So many system calls we will use during our lab. Okay, now okay, we are talking about memory, main memory. So what are the 3 major activities of operating system in regard to memory management? Whenever we are talking about, okay, we have to do memory management. Okay, so what operating system will do in this regard? So operating system has 3 major activities in regard to memory management. So 3 main thing operating system is doing. Okay, so what it is doing? Keep track of which part of memory are currently being used and by whom. Okay, now let's suppose if I draw here somewhere, okay, this is your memory, and we know that memory is in somehow matrix form, it is divided into blocks. So this is just, we suppose that this is our memory, and this is responsibility of operating system that which part of this memory are in use. Okay, and if they are, you suppose we have one variable a, okay, we given this space here, and another variable, maybe this another variable, we assume that b. So currently if you see here that 2 block of this memory are filled, this one and this one. So this is responsibility of operating system to keep track that which part are currently being used. So here it means the this part 1, and maybe we say okay 1 2 3 4 5 6 7 7 1 and 7 are in use, but remaining 2 3 4 5 6 8 9 10 11 12, total 12 block we have. So 2 are in use, 10 are free, but who is using them? Of course this is some address, this first one there is some address, this memory address. So who is using them? The variable b. Suppose b is a variable, and who is using this block? Variable a. So this is responsibility of operating system that keep track of which part of memory are currently being used and by whom and who is using. Okay. Second thing that operating system have to do, decide which process are to be loaded into memory when memory space becomes available. Okay. Now whenever we have many processes, okay, they are waiting for memory. So operating system will decide which process we need to load into the memory. We have one queue. Okay, so we will discuss in coming slide that in queue we put some process, many process, and whenever memory will become free, then operating system have to decide which process to load into the memory. Okay. Third thing, that is allocate and deallocate memory space as needed. So give the memory and take the memory back. Okay. So these are the three main things that operating system have to do in regard to memory management. So what is first one? Keep track of which part of memory are currently in being used and by whom. Being used and by whom, which are in use, okay, which are already free, already occupied, and who has occupied that space. Okay. So decide, to make decision which process to load into the memory. Okay. So when you have memory, so which process we have to load? Maybe we have 10 process in a queue, but we have to decide how much memory we have and how much process we can load. Maybe only one process. So from that 10 process we need to decide which process we need to load. And third thing, to allocate and to deallocate memory space whenever it is needed. Okay. So these are the three main things. Now we will make some discussion about secondary storage device. Okay. Secondary storage devices, as this is very simple that secondary storage devices is a medium that hold information until it is deleted or overwritten. So these are permanent storage. So permanently, if you want to store any data, this, if you see this figure or this floppy drive, okay, these are examples of permanent storage. Currently we are using also flash drives. Okay, we are using DVD, we are using CD. Okay, so these mediums, in these mediums, data that we are storing, that will be stored here permanently until we delete that data or we overwrite data. Okay, so secondary storage devices does not lose the data when the device is power off, power down. Okay, so this is not like a main memory. So this is the difference between main memory and secondary storage device. In main memory, whenever you will switch off your machine, you will power off, then it will be, the data will be deleted because that data is temporarily coming in. Okay, so we say that the concept in operating system we use, this is non-volatile, that the thing that you will store, it will not lose until you have deleted that file or you have overwritten that file. Okay, so this is the difference between main memory and secondary storage devices. So in figure you can see floppy drive, that is here, that this is very old technology. Currently we are not using, instead of this we are using flash drives, we are using DVD, we are using CD. Okay, so all these are non-volatile. Volatile mean that the information that you have, it will be lost when you will switch off your machine. Okay, so now we have seen the three major activities of operating system in regard to main memory. Now also operating system is doing three things, three activities regarding to secondary storage management, how it is managing this storage device. Okay, also operating system, these three include free space management, that operating system, this is responsibility of operating system to manage the free space on secondary storage devices. Okay, so storage management, how to store the data. Okay, because if you see, we have different sectors, we have different sectors in our secondary storage devices, and like this is our, suppose this is our secondary storage devices, it is always divided into different sectors. Here suppose we don't know, whenever we are giving command to store data, we are not telling to store in which sector, these are logical. Okay, so we are not telling the system where to store data, operating system is doing this. Okay, storage management, maybe he store my information here at this place, or maybe at this place, or this place. So we are not telling to operating system where to store, this is responsibility of operating system to manage this. Okay, so third one, and that is disk scheduling. So we have some scheduling algorithm, first come first serve, shortest seek time first, and so on. We have many different algorithms for disk scheduling. Okay, so we have three activities that operating system is doing for secondary storage management, that is free space management, how much space is available. Of course it has some information that we have, maybe our disk size is 10 GB, maybe we have some data, and how much space is free, maybe 8 GB. Okay, so this is called free space management, how much free space we have. Then we have second thing, storage management, how to store data and where to store, and the third one is disk scheduling. Okay, now scheduling queues. Now for this one we need to go back to our state diagram. In state diagram we have seen that we have 5 different states, and there are 3 important states, that are ready state, waiting state, and running state. Okay, so whenever a process enter the system, they are put into a job queue. Okay, when the new process is coming to the system, which consists of all the process in the system, so we have 2 important queues in our system, that is, first is ready queue. Okay, second is device queue. Ready, the process that are residing in main memory, and ready and waiting to execute are kept on the list called ready queue. So the process, when it will come to the system, so we need to put that process in a one queue, that is called ready queue, on ready state. In ready state, in our state diagram we have one queue, that is called ready queue. Okay, so here all the new coming process we will put in ready queue, and it means they are ready for execution, they are ready to move to the running state, but they are waiting. Okay, they will wait in ready queue until the scheduler move the process from ready state to running state. So this queue will be on the ready state. Okay, so we will put all our process in ready queue for execution. Second queue, that is the device queue. Okay, suppose the process make an IO request to a shared device. Now you have seen in state diagram we have one state, that is called waiting state. So maybe one process needs some IO device, and he will be moved to the waiting state until he get his required device. Okay, so over there we need to make one queue, that is called device queue. So this queue will be in waiting state, suppose the process make an IO request to a shared device such as a disk. Since there are many processes in the system, the disk may be busy with the IO request of some other process. Maybe that some other process is using that IO device. The process may have to wait for the disk. Okay. So in this case, the process need to wait for the disk. The list of process waiting for a particular device is called the device queue. Okay. So we have to put the process in that queue. Okay. So when his request will be fulfilled, then we have to again move this process to ready queue, ready state, and from ready state he will go to the running state. Okay. So we have two type of process, ready and device. Now next, if you see this figure, that process is available in ready queue, and when the scheduler will move this process to the CPU, okay, CPU for execution. Now we have some possibilities. Maybe from here he finish his work and exit, terminate. The process is terminated. Or maybe he gives some IO request and process move to the IO queue, okay, or device queue, and from device queue again he will go to ready queue, and from ready queue again to CPU. This is option 1. This is first possibility, that from running state it is moved to the device queue, okay, or we say also IO queue, input output queue. He make one request and move to IO queue. Second possibility is maybe his time slice is expired. His time is expired, and after that it is moved back to the ready queue. So this is also move back to the ready queue. Again he will wait here for his turn until to reach to the running state. This is second possibility. Or third one is maybe he fork a child, maybe he given command, he created a child process, and the child process start execution, and it is now going to ready queue again. Okay, after child finish execution, then go to ready queue, parent went back. Or wait for interrupt, an interrupt occur, and now his interrupt occur, and again he is going back to ready queue. Okay, so we have different possibilities when the process is in execution. Okay, so this is explaining we have two different queues, ready queue and device queue, are also here they use the word IO queue. Okay, so we have two queues, ready queue and device queue. Okay, now today our last thing is that which event could occur when a process is allocated the CPU and is executing. So whenever process is in execution mode, mean it is in running state. So what possibilities, what event can occur? When a process is executing, then following events can occur. There are three main things. The process could issue an IO request and then be placed in an IO queue. Okay, so if you go back again, maybe this is first possibility, that he is asking for IO device and it go into the IO queue. This is first thing. This diagram clearly shows that this is first possibility, that if maybe issue an IO request and it will be placed into the IO queue. So what is IO queue? This is also device queue. Or second possibility is the process could create a new sub-process and wait for sub-process termination. Create a new process. Okay, so here we are going to use the system call fork to create a new process, and that new process is called child of that process. So he created a new process and now he is waiting for process to terminate. Okay, so if you go back this figure, that this possibility, if you see the possibility from here, you are you are going here, that fork a child mean to create a new process, and now you are waiting the child execute, and then when child execution is finished, then start the parent execution. Okay, the process could be removed by force from the CPU. Okay, by force mean maybe the time slice is expired and now the interrupt came as a result of interrupt that put back into the ready queue. The process is moved back to the ready queue. See here that maybe time slice expire and again is going back to ready queue, or maybe the next is wait for interrupt occur and it is going back to the ready queue. Okay, so we have three things. Whenever the process is in execution mode, then maybe the first one is process request for IO device, and then is event back to the IO queue for the request fulfill. When the request will be fulfilled, then it will be moved back to the ready queue. Or second possibility is that he create a child process or sub process and waiting for sub process termination. Now these sub process may be one process, two process, or because he can create many process. So he will wait, and then when their execution will finish, then he will execute himself. Or process could be removed by force from the CPU. It's possible that process is removed by force, okay, as a result of interrupt and put back into the ready queue. Okay, so this is our second session of our lecture 4. So we will just take quick overview what we discussed today. So we start our discussion from process creation, and we have said that we have two main operation: process creation and process termination. So what is process creation? To create a new process. When we will create a new process, then we have two processes. Then one is called parent process and another is called child process. Then we have seen that each process have a unique process ID. So one process can create maybe more than one process, but process ID must be unique. So process termination. So how we will terminate process? By using system call exit. Okay. So termination is to remove from the memory. Then we have seen what are the three activities of operating system in terms of memory management. We said that first is to keep track which part of memory are currently being used and who is using them. Okay, so decide which process are to be loaded into memory when the memory space is available. Then we have seen allocate and deallocate memory space. Then we have discussed secondary storage devices. These devices are non-volatile devices, because non-volatile mean that the information or data that we have written, it will not be deleted when we will power off our system. Only possibility to delete is if we are deleting them or we are overwriting them. Then we discuss some three major activities of operating system in terms of secondary storage devices, and these are free space management, storage management, and disk scheduling. We have two type of different queues, that is ready queue and device queue. Okay, and we discuss the diagram. Then which events could occur when a process is allocated to CPU and is executing. We said maybe during execution he issue a IO request, and due to this request it is put into the IO queue or device queue. A process maybe create a new child process and is waiting for the termination of child process. Okay, and maybe it is moved to the ready queue by force. Maybe its time slice is expired or due to any interrupt that is put into the ready queue. Okay, so if you have any question, you can send me email or you can visit my office during my office hours, okay, to ask the question. Thank you very much and see you in lecture number 5.